Hello, welcome again. We are covering GATE Aerospace Engineering syllabus. Section 1 is Engineering Mathematics and the core topic is calculus. And now we will discuss differentiability. So definition of differentiability is a function is differentiable everywhere if its derivative is defined. Okay. So differentiability means its differentiation can be done. Okay. As long as you can evaluate the derivative at every point on the curve, the function is differentiable. Okay. So this definition can be best understood with some examples. Suppose we have function fx is equal to x square, that is for all real numbers, and the differentiation is 2x. Okay, so it is differentiable at all points for all real numbers. Now consider another function fx is equal to modulus x. So this function modulus x can be written as minus x when x is less than 0 and plus x when x is equal to greater than 0. So for x less than 0, we take this equation, that is minus x, and f dash x will be at minus 1. So it means when x is less than 0, it is differentiable at all the points. Okay. And when x is greater than 0, then fx is x, and it is differentiable, and its differentiation is 1. So it means it is differentiable at all the points when x is greater than 0. Okay. So this fx is equal to minus x is differentiable when x is less than 0. Okay. And this fx is equal to x is differentiable when x is more than 0. But at x is equal to 0, we don't know which we have to take, minus x and x, because so it is not differentiable. So there is one more way to interpret this differentiability. At the point where the curve changes its nature, the function is not differentiable. So if we draw this function, okay, for minus x, this will be the line. For plus x, this will be the line. So it means there are two lines, and two lines meet at this point. So two separate curves meeting at x is equal to 0. So at the point of intersection, this is not differentiable. The function differentiable when x is less than 0 and when x is more than 0. But at the point of intersection of two curves, the function is not differentiable. Okay. So for the differentiation, we need a single equation. So there exists a single equation for this line, there exists a single equation for this line, but for both of these lines there are two different equations, and at the point of intersection it will not be differentiable. Okay. So that is the differentiability. So when the curve changes its nature at the point where the two curves meet, two separate line or curve meet, the function is not differentiable. Okay. So however, in this example, fx is equal to x square, the function is continuous because it can be drawn without lifting any pen from the paper, and this can also be drawn without lifting any pen from the paper, but it is not differentiable at, the second function is not differentiable at x is equal to 0. Okay. So there is one result can be interpreted in this: whenever the function is differentiable, it will be continuous function, but reverse is not true. So here we can see that both are continuous function. Okay. So whenever the function is differential, then it means it is represented by a single equation, and single equation line or curve are continuous. Okay. So when there is change in nature of the curve, there is then at that point the function is not differentiable. Okay. So that is one.